You're listening to the Seen and Solved podcast, brought to you by Hubbard-Hall. Better results, less chemistry.
So welcome to this edition of Seen and Solved, presented by Hubbard-Hall. I'm Tim Pennington, editor-in-chief at finishingandcoating.com. And today we're talking with Jason Potts, who's the product manager, Northeast Metal Finishing for Hubbard-Hall. And our topic today, something that I know is really something the industry talks a lot about, is can be kind of tricky, electroless nickel. So we're going to talk to Jason about that. Jason, thanks for joining us today. We appreciate it.
Thanks for having me. It's an exciting topic for me.
Yeah. How many years have you been involved overall in electroless nickel, would you say?
Total, 30. I'm going on 30 years. I started off in a plating shop, went into, from there, it went into the manufacturing, selling, the service of it, and stayed on that side, this side of the business ever since then. So, and I've seen it evolve over the years, which has been really cool, to be there when, from the beginning of it, when there was basically, three baths to where there's so many different chemistries out there now. So it's been a good ride.
Right. Yeah, like I said, and somebody asked me the other day what percentage they thought of the finishing industry is performing electroless nickel. It's not a lot. I mean, it's not a huge amount of people, right?
It's not. I don't know the exact. That's a good question. The problem with it over the years is disposal of it, waste treatment cost of it, the cost of it. To use it, which we'll talk about, as we get into this. But I definitely have seen over the years that it's decreased, in certain sectors, but then in other applications, there has been an increase in it too. So I think it from year to year it changes, depending on what's out there. The EV market, I think, is starting to bring it back a little bit.
Right. Yeah, I think so too. Yeah. So let's talk about something here. The three common families of electroless nickel. What are they? What's the differences between the two, or between the three, I should say?
Yeah. So the three different, I guess, there's several different families, but the three most common would be the low phos, mid phos, and high phos. We're not going to talk about the composites today. The composites being Teflon, boron nitride. You could do silicon carbide, diamond. That's a different topic. But in the industry, mostly we're seeing low, mid, and high, with most of it being in the mid phos sector at this point. So with the low phos, it's typically 1.5 to 4% phosphorus. It's a hard coating, running about 60 Rockwell, I would say. It's a fast plating bath. It'll plate about a thousandths an hour. It's considered more of a satin to a semi-bright bath. It has good corrosion resistance in alkaline environments, but in other environments, I wouldn't say very good. Actually, way back when I did some testing in our R&D lab, and it was on springs for I think Clorox spray bottles, and they were having a problem with corrosion, and it showed that the low phos actually performed better than anything else, and that's what they went with. Melting range has a range of 2,200 to 2,500 Fahrenheit for a range. There's actually no melting point on any of the EN chemistries. It's a range based on the phosphorus that's in there, because you have a range of phosphorus. And you can go 8 metal turns on ferrous and copper substrates. You get into the aluminum, you're still in the 4 to 6. So that's the low phos. Going into the mid phos is typically 7 to 9%. Oh, let me back up. There is a low mid phos bath that does 3 to 6%.
Right.
I didn't include that because it's not used as much. So that's the difference why you're seeing from 1.5 to 4 to 7 to 9% going to the mid phos. Mid phos is it's a little harder. Rockwell 48 for hardness. Its plating speed is about the same as the low phos. It can be a little faster on makeup. Some of these new mid phos baths will plate 1.2 mils an hour, which is pretty fast. It's bright to a mirror bright. Over the years, the mid phos used to be more of a functional coating. Over the years, it's been changed more into a we want bright. With bright comes problems, but it can be a very bright, mirror bright bath. So it's a very decorative bath. It can be used as a decorative bath. The deposit itself is tensile, meaning that it wants to pull away from the substrate. Therefore, the corrosion resistance isn't the best either, because it's always wanting to pull away, and you could get undermining and attack the substrate. The corrosion resistance. So neutral salt spray itself, and we'll see the difference when I talk about high phos. You'll get about 100 hours to red rust with a thousandths or 1 mil with phos, which is not very good. It's really not designed for that, for the corrosion resistance, I should say. Melting range is about 1600 to 1700 range, and you can also plate up to 8 to 10 metal turns. I saw a customer one time do 20 metal turns. It's a waste of time, but 8 to metal turns before you have to dump the bath and make it up new, and that's on ferrous and copper substrates. Of course, aluminum is less than that.
Right.
And then we talk about the high phos. So the high phos is the typically 10 to 12%, and that's the softest of all the deposits because of the higher phosphorus. And their Rockwell comes in around, I gotta think, let me think, 45, about 45 Rockwell for the high phos. It's a slower bath. It's only going to plate about 0.6 an hour. You can plate a little faster. You're going to manipulate your phosphorus down to a range where you're not going to meet your spec, but you can also plate slower and bring that phosphorus range in the 12s very easily, which will give you very high corrosion resistance. And the corrosion resistance in neutral salt spray as compared to the mid-phos that we spoke about earlier, you'll get 1,000 hours to red rust with the same thickness of 1 mil.
Gotcha. Right.
So, and this is a compressive stress bath, so it stays compressive up to 4 metal turns. There are additives out there you can add to keep it compressive, but typically 4 metal turns, you stay compressive. And then again, I would say for ferrous and copper substrates, you're going to be around 4 metal turns again, but you can bring it out longer if need be, if you don't care about that corrosion resistance. But your best corrosion resistance is going to be that 0 to 4 metal turns for the high phos.
Right. So is that what determines what they're going to use? Is it the hardness? Is that what specs?
Typically, it's the phosphorus limit. I mean, in some of the specs, they call out a hardness, which the phosphorus is going to manipulate that hardness, and you can heat treat any of these to get to a certain Rockwell, depending on what they're looking for. But typically, it's when they call out, a customer calls out, they need something. The customer wants, I need 3 to 6%, or I need, an 8% phosphorus or a 10%, and that'll tell us. Once it tells the phosphorus, we know what bath they want to use, what they're looking for.
Gotcha. Okay, so let's talk about this. The advantages of using electroless nickel as opposed to electrolytic nickel. What are some of the advantages?
One of the biggest advantages, in my opinion, for electroless nickel, and it's called the dog boning effect. People in the plating industry understand dog boning, but for those who don't, dog boning, if you look at a dog bone that goes like this, and you've got the outer edges and it comes back. Right. On Electroless, if you want to put a thousandths in the middle of that, you could put a thousandths in the middle, a thousandths on that edge, the edge of the dog bone, and it'll be a thousandths all the way around. With electrolytic, in order to hit a mil or a thousandths in that middle, you may have to be 1.5 on those. Okay. So you might have to hit 1.5 to get that thousand. So that's a huge advantage, because then you don't have to machine back down. Typically with electrolytic, if you do something like that, you have to turn it back down if you're doing any types of rolls or anything of that nature. So it's a much easier bath to, I shouldn't say bath to operate, but an easier process by doing electroless nickel as opposed to electrolytic for the dog boning effect. Other advantages is racking. You don't have to secure your parts very well. Like with electrolytic nickel, you have to have good solid contact. You have to be careful on how you configure the parts. You don't want to have the parts too close to an anode in electrolytic. With electroless, you don't have anodes. You don't have racking considerations. You can put as many parts as you want on that rack, and they're all going to plate the same. As long as you have good solution flow and there's no stratification, of course, of any kind of heat variances. And if you're controlling your bath, that's another good advantage there. Again, with also tank orientation. With no anodes in the tank, you have much more room in that tank. A nickel, electrolytic nickel has anodes in there that'll take up some space. You don't have that in electroless, but some electroless tanks actually do have, and so it's not the best design. They do have their filter bags inside of the tank, and sometimes they have over the side heating coils, which take up some room, but not as much room as an electrolytic bath. So those are some of the main advantages over electrolytic. And if you want to talk about disadvantages,
well, I was going to say, yeah. So, what are the drawbacks to that as opposed to where does it not work as well as you think?
Well, I would say maybe not work as well. The plating speed, I would say the plating speed is slow. You could plate faster in electrolytic, but again, your disadvantage is that dog boning effect. The EN is typically more expensive because you're plating out of the solution. You're adding back chemistry in electroless nickel in order to maintain your range, whereas an electrolytic bath, you do add back some chemistry, which are the additives that you need in that bath, but you're plating out of the anodes. Right. So it becomes more expensive. Pre-treatment, in my opinion, I think many other EN platers' opinion also will be the same. Pre-treatment you have to be on top of your game with pre-treatment with electroless nickel.
Right.
It just has to be more of not a pristine pre-treatment, but you have to pay attention to it more than electrolytic. Electrolytic seems to be a little more forgiving. A lot of times with electros, I always recommend doing a double clean. If you have that capability, just do a double clean, and you're going to be in a much better situation double cleaning than single cleaning.
Mm-hmm. Right. Yeah. Like I said, it's like I said, it's got the advantages and disadvantages. I hear a lot from my time. I know that I know troubleshooting is sometimes an issue with this. Give me some examples of where you've kind of gone in, you've had an issue with a shop they couldn't easily solve it. What were they, and then what were some of the corrective actions that took place?
So one of the hardest issues I would say, or one of the hardest things that can happen, and it happens on the parts itself in electroless bath, is roughness. Whether it be pitting, outgassing, or just general shelf roughness. That is a common problem. A lot of times it's more in the heavy build applications. To find the source of that is probably one of the most difficult things to do, because there's you go into a plating shop. Some plating shops are extremely clean. So you typically overlook the areas that you would think that would, that could deposit particles, maybe off a hoist or sandblasting operation that might be close by, or contaminated water, any kind of changes. So roughness is probably one of the most difficult troubleshooting processes to do on electroless nickel, in my opinion. And you get it, like I said, typically in the high build applications, which is 1,000s or more, and a lot of times it's with high phos. The other issues, you're always going to get played out. The bath will eventually plate out. There's really nothing you can help the plate out. So I guess you can help troubleshoot that. The plate out could be from, again, particles, parts in the bottom of the bath starts to plate out. It could be poor equipment or poor stripping procedures. And every bath is eventually going to plate out, so you have to eventually dump it and make up new. And you just want to make sure that once you get the plate out and you start to strip the bath down, your nitric has to be in less than 4 ounces per gallon of nickel. It has to be 50% concentration would be the best. So plate out is also an issue. Don't see it much very often, but a whiteout. So a whiteout can happen typically when you lose bath solution. A lot of times the operator, the plater, doesn't realize they're losing bath solution because they make the bath up and then you just keep plating, and they're like, well, how am I losing bath solution? I'm not dumping it out, I'm not pouring it out, I'm not overflowing the tank. But if you look around the plumbing areas, sometimes you'll see major leaks that they don't see. So once you leak the solution out, you're not coming back with the complexers that you need to keep the bath, the nickel in solution, and you'll get a whiteout. And then a whiteout, you're going to have to, you typically have to drop the pH. You drop the temperature, drop the pH, get the nickel back in solution, add back some of the complexers, and then bring it back up. And it's very time consuming. Very time consuming. One other one, slow plating rate is an issue. That could be bath imbalance. It could be contamination. EN is very easily contaminated as compared to electrolytic. Parts per million of certain metals can cause that. So it can be a sensitive bath, but it's a great bath. It's a great bath for many things. And like with any, chemistry or electrolytic or electroless bath, you're going to have issues with it like that.
Right. What product lines does Hubbard-Hall have for the EN lines? What do you guys have available for them, for customers to use?
For the actual manufacturer of the products?
Yeah.
So MetalChem. We use MetalChem. They
Okay.
supply us with our Electroless nickel, and we work closely with them. We partnered with them to where we talk very openly about their chemistry, and when there's problems, if there is problems that are serious enough, they make visits with us, they make calls with us. They've been a really good partner with Hubbard-Hall.
Right. Yeah. Some of the best around right there. I mean, that's experts in that. So, well, that's great. Like I said, thanks, for kind of explaining some of those things. You answered one of the questions I had was the differences and the reasons people would use it, maybe not use it, but great. And like I said, people can go to Hubbard-Hall's website or even give you what is your email address? jpots, is that right?
jpots@hubbardhall.com.
Right. Give you a call. I know a lot of people that do have questions in this realm, so I do appreciate you taking time with us today.
Absolutely.
Okay, and great. And again, you can go to Hubbard-Hall, see more of the seen and solved issues, or you can visit hubbardhall.com. Thanks, Jason.
Thanks, Tim.
Thanks for listening to Seen and Solved by Hubbard-Hall. For more episodes, visit hubbardhall.com or wherever you get your podcasts. Be sure to like and subscribe, rate and review, and join us on social media. Produced by Awcast.